Exploring super-Earths, a mysterious new class of exoplanets. The universe is vast, ancient, and filled with secrets. As we peer further into the darkness of space, we find that our understanding of the cosmos is limited. Our galaxy, the Milky Way, contains hundreds of billions of stars, each with the potential to host planetary systems. One of the most fascinating discoveries of recent years is a class of exoplanets known as super-Earths. These planets, larger than Earth but smaller than Neptune, occupy a mysterious space between rocky worlds like our own and the giant gas planets. But what exactly are super-Earths? What makes them so unique? And perhaps the most tantalizing question, could they harbor life? What are super-Earths? The term super-Earth refers not to the composition of the planet but its mass. Super-Earths are exoplanets with a mass between 1 and 10 times that of Earth. Some are rocky, while others could be water worlds, icy or gas-rich. Their sizes vary widely, but they all share one common trait. They are larger than Earth, yet much smaller than the gas giants of our solar system like Jupiter and Saturn. Despite the name, super-Earths are not necessarily habitable. In fact, the diversity of this class of planets is staggering. Some super-Earths may have thick atmospheres composed of hydrogen and helium, making them more like mini Neptunes. Others might have thin atmospheres with surface conditions that are scorchingly hot or bitterly cold. The sheer variety of these planets means that while some might resemble Earth in size, they could be radically different in every other aspect. The discovery of super-Earths. Super-Earths were first discovered in the early 1990s when astronomers began hunting for planets beyond our solar system, or exoplanets. Initially, most of the exoplanets discovered were gas giants like Jupiter, which are easier to detect due to their massive size and gravitational influence on their parent stars. However, as detection techniques improved, scientists began finding smaller planets, some only a few times larger than Earth. These discoveries challenged our understanding of planetary formation and opened a new frontier in the search for habitable worlds. One of the most groundbreaking discoveries came in 2009 with the launch of NASA's Kepler Space Telescope. Kepler's mission was to stare at a patch of sky and monitor over 150,000 stars for tiny dips in brightness, which could indicate a planet passing in front of its star. In its lifetime, Kepler identified thousands of exoplanets, including many super-Earths. This new class of planets has since become one of the most intriguing areas of study for astronomers. They are plentiful in our galaxy, far more common than Earth-sized planets, and many reside in the so-called habitable zone of their stars, the region where conditions might be right for liquid water to exist on a planet's surface. The enigma of super-Earth composition. Super-Earths are, in many ways, enigmas. Their larger sizes mean they could have a range of compositions, and current detection methods make it difficult to know exactly what they're made of. Some super-Earths may be rocky like our planet, with mountains, valleys, and possibly even oceans. Others might be enveloped in thick, crushing atmospheres filled with toxic gases or possess icy exteriors with frigid temperatures. The diversity in possible compositions means that super-Earths could be as varied as the stars themselves. One of the most debated aspects of super-Earths is their atmosphere. A thick, hydrogen-rich atmosphere could create surface conditions that are too hostile for life as we know it. On the other hand, some super-Earths might have thinner Earth-like atmospheres with just the right combination of gases to support life. The key to understanding these planets lies in determining their atmospheric composition, which remains one of the greatest challenges for astronomers. One of the most promising techniques for studying the atmospheres of distant exoplanets is transit spectroscopy. When a planet passes in front of its star, a small fraction of the star's light filters through the planet's atmosphere. By studying this filtered light, astronomers can identify the chemical composition of the atmosphere. This method has already been used to detect water vapor, carbon dioxide, methane, and other compounds in the atmospheres of exoplanets, including some super-Earths. Potential for life on super-Earths. Of all the questions surrounding super-Earths, perhaps the most tantalizing is whether they could harbor life. In our search for extraterrestrial life, we often look for conditions similar to those on Earth. This is because, as far as we know, life requires liquid water, a stable climate, and an atmosphere with essential gases like oxygen and carbon dioxide. But could life on super-Earths exist in forms that are radically different from anything we've ever imagined? The possibility of life on super-Earths hinges on many factors. First, the planet must reside in the habitable zone of its star. However, simply being in this zone does not guarantee habitability. Venus, for example, lies within the Sun's habitable zone, but has a surface temperature hot enough to melt lead due to its thick, toxic atmosphere. Similarly, many super-Earths might have extreme surface conditions, rendering them inhospitable. However, there is also a chance that some super-Earths could have conditions that are more favorable to life. Their larger size could mean a more substantial atmosphere, which could help regulate temperatures and protect the surface from harmful radiation. Some super-Earths might also have magnetic fields, which are essential for shielding life from cosmic and solar radiation. On Earth, our magnetic field is generated by the movement of molten iron in the planet's core. It is unknown whether super-Earths have similar mechanisms, but their larger mass could result in even stronger magnetic fields. Another factor to consider is the possibility of water. Super-Earths that are too close to their stars might be dry and barren, while those that are too far away could be frozen wastelands. However, there is evidence to suggest that some super-Earths could be covered in vast oceans. Water is essential for life as we know it, and the discovery of ocean worlds among the super-Earths would significantly increase the chances of finding life. One such intriguing planet is Kepler 22b, a super-Earth located about 600 light-years from Earth. It lies in the habitable zone of its star, and while its exact composition is still unknown, scientists speculate that it could have a liquid ocean covering its entire surface. If true, this would make Kepler 22b one of the most promising candidates for hosting life. The challenge of exploring super-Earths. Despite their promise, studying super-Earths is incredibly challenging. Most of these planets are located hundreds or even thousands of light-years away, making direct observation difficult. We rely on indirect methods such as measuring the gravitational effects of these planets on their parent stars, or analyzing the light they block as they pass in front of their stars. Even with powerful telescopes like Kepler and the upcoming James Webb Space Telescope, our understanding of these distant worlds is limited. However, new technology is constantly improving our ability to study exoplanets. The James Webb Space Telescope, for example, is equipped with advanced instruments capable of detecting the faint signatures of molecules in the atmospheres of distant exoplanets, including super-Earths. This will provide us with unprecedented insights into the conditions on these alien worlds. But for all our technological advancements, the idea of visiting a super-Earth remains in the realm of science fiction. Even the closest exoplanets are located many light-years away, making human exploration an almost unimaginable task with our current capabilities. However, as we continue to push the boundaries of space exploration, who knows what the future might hold? What super-Earths teach us about the universe? The discovery of super-Earths has revolutionized our understanding of planetary systems. For decades, we believed that our solar system was a typical example of planetary formation, with small rocky planets near the sun and gas giants further out. However, the abundance of super-Earths has shattered this notion. In fact, most planetary systems in our galaxy appear to contain planets that are vastly different from those in our solar system. Super-Earths also challenge our assumptions about habitability. While Earth-sized planets in the habitable zone are still prime targets in the search for life, the discovery of potentially habitable super-Earths has expanded our horizons. These planets could offer more stable climates, stronger magnetic fields, and a greater likelihood of having liquid water, all essential ingredients for life. Moreover, studying super-Earths forces us to confront some of the most profound questions about the universe and our place in it. Are we alone in the cosmos? What forms might alien life take on these distant worlds? Could these planets harbor advanced civilizations, or are they desolate, lifeless places? The future of super-Earth exploration. As our technology advances, we will continue to unlock the secrets of super-Earths. The upcoming generation of telescopes, such as the Extremely Large Telescope, ELT, and the James Webb Space Telescope, promises to revolutionize our ability to study these distant worlds in greater detail than ever before. We may soon be able to answer some of the most pressing questions about their composition, atmospheres, and potential for life. In the end, the exploration of super-Earths is about more than just discovering new planets. It's about expanding our understanding of the universe and our place within it. Each new discovery brings us closer to answering one of the most fundamental questions in human history. Are we alone, or is life a common occurrence in the vast, dark reaches of space? Super-Earths offer hope. They represent the possibility of new worlds, new life, and new discoveries that will reshape our understanding of the cosmos for generations to come. As we continue to explore these alien worlds, we are not just searching for life, we are searching for a deeper understanding of our existence and the infinite mysteries that lie beyond the stars.